Hey guys. So here is your deep dive with osmosis, starting with these fun gummy bears, right? We're going from that smaller gummy bear, and then after it's in water, right? It's obviously getting bigger, which means water is going in. We're going to talk about why that happens in these next couple of videos that you're going to watch today. Okay, so osmosis is the movement of water through diffusion, which is passive transport, right? It doesn't take any energy. Cool. Where is there more water in this example? I want to start with this question. Take a look and answer on the Edpuzzle. Great. So you should have seen, right, that there's more water on the right side, those small dots, okay, because they show that there's more of them here, and there's less sugar. There's more sugar here and less water. So where do we think water is going to move via diffusion? It's going to move to a lower concentration of water, okay? Diffusion happens, you go from high concentrations to lower concentrations, okay? So water is going to move across this semi-permeable membrane from higher concentrations of water to lower concentrations of water, okay? Great. So next we have, I just want us to really stamp this idea of osmosis, right? It is the diffusion of water with the concentration gradient, okay? With its concentration gradient. So it goes from high to low concentration of water, okay? In your notes, I not only want you guys to stamp this, but I also want you to make sure that you have a diagram of some sort. So here we have more water. We actually don't have any solute here. But on the right side, you can see that there's less water because there is higher solute concentration. Water is going to move to where there is more water, or where there is more water to where there is less concentration of water. Okay, great. Make sure that you get that done. You can feel free to pause if you need to. So ultimately, the purpose of this, right, is to achieve homeostasis. So when osmosis makes water move from high to low concentrations, okay, via this diffusion, right, the spreading out and creating equilibrium, okay, what happens is we don't have the same amount of water here, but we have the same concentration, right? Now we have equilibrium in the concentration of solute in the water, okay, and this solute can be anything. It could be salt, it could be sugar, right? We're saying solute just as a general. Okay, great. So I want to do a couple quick checks for your understanding. So first, which way will water move via osmosis in this example? Go ahead and write it into the Nearpod. Great, and you should have gotten that you're going to go from B, okay, where there's more water, to A, where there's less water. Okay, so from B to A or from right to left. Good. Try another one. Okay. Which way will water move via osmosis in this example? Think, where is there more water? Nice. So you guys should have, right, an arrow or writing that you're going from the left side to the right side. There is more water concentration on the left side, so it's going to move from high water concentration to lower water concentration on the right. Okay. Nice job. So a couple other pieces of information I want you guys to have. More vocab that you're going to see that's the same concept, okay? Osmolarity is a word that you will see that refers to the number of particles in a solution compared to water, right? So it's like the concentration of solute. Um, the greater the osmolarity, the greater the concentration of solute, okay? So you may see uh, this is saying low osmolarity to high osmolarity, which means there's a lot of solute here and there's not a lot of solute here, meaning there's a lot of water here and there's not a lot of water here. Okay, so high osmolarity, right? Think molarity talks about the concentration of solute. That means that there's a higher concentration of solute, so less water. Okay, you don't need to know how to calculate osmolarity for this class, but you do need to know what the word means. Okay, so I wanted to make sure to go over that. Beautiful. Next, we have our different types of solutions. Okay, so in osmosis, you are going to hear these words a lot: hypotonic, hypertonic, and isotonic. Okay, so this concept is also called tonicity, right? So the strength of these environments. And it specifically refers to how much water and how much solute they have in them. So hypotonic refers to an environment that has a lower amount of solute relative the other solution. Okay, let's look at hypotonic down here. So a hypotonic solution is this blue part. Okay, there's only one of the solute and there's a lot more here. So the hypotonic solution doesn't have as much concentration of solute. Okay, and it also has a higher concentration of water. Okay, so we have hypotonic and hypertonic. I usually think, okay, of hypo as being, it means lacking, but I like thinking of hypo like there's an O in this, right? So H2O, hypo has more H2O, okay? So this has more H2O, okay? Great. The hypertonic environment, right, means it has a higher concentration of solute outside, right, in the environment we're talking about, whichever environment we're referring to. And in this case, it has a lot of concentration. Okay, high concentration of solute. I always think of this as like sugar, right? When you drink a lot of sugar, you eat a lot of sugar, you get really hyper. Okay, so this means a lot of solute. Okay, solute. This is very hard to do on my computer. Beautiful. Okay, and then iso means equal. So isotonic means that they're the same, okay, relative the other solution. Okay, so what does this tell us about our solutions? Well, this is what it tells us. In a hypotonic solution, meaning there is a cell that is in a solution that has a lot more water, water is going to move into the cell from high to low concentration. And guess what's going to happen? The cell could potentially burst. Okay, if you put a cell in water, okay, there's a lot of water on the outside is going to rush in and burst the cell. When that happens in plant cells, like you can see here, they just get turgid, right? Where they get very stiff, right? And they have a lot of water in it because they have that big vacuole that helps keep that in their cell wall. Okay, sorry, that is my dog. Great. So then we have the isotonic solution. We're going to have some water come in, some water go out, but overall the net movement is equal. Okay. And then in your hypertonic solution, right, there's more water on the inside of the cell. The water will move out. Okay. And it will shrivel. It'll get smaller. Okay. So go ahead and make sure that those 3 words and a diagram are in your notes. And now we're going to do some practice. So what type of environment is this cell in? Go ahead and write it into the Edpuzzle. Nice. So you should have had hypertonic because the cell is an environment with greater salt concentration. In this case, this is salt, right? And less water. Good. So it should have been A, hypertonic. So then what's going to happen to the water? What is the net or overall movement of water in this example? Is it into or out of the cell? Go ahead and put it into your Edpuzzle. Yeah, it should be out of the cell. Okay, if you did not get that correct, make sure you're listening to the reasoning here. Water will move out of the cell from higher concentrations of water, right? Meaning the inside of the cell is hypotonic, it has more water, to a lower concentration of water, the hypertonic solution. Okay, so water will move from the inside of the cell to the outside. Okay, great. So I'm just gonna go. I'm gonna go ahead and give you guys the last 30 seconds or so. This should stay up and you guys can pause this to make sure you have your key points into your digital notes. You can also write these down if you feel like doing that first, and then you can record them into your digital notes. You should take a minute to make sure that you have these stamped, and then we will come back together.